Thank you, and thank you for the opportunity to present with Zahn Dental. My name is Graham Turner, and I've got my colleague on with me, Corey Lambertson, who's in the process of opening an office in the US. So we have an American-based training center now. And this webinar is basically going to go through just more detail around our products for dentistry and how they're suited for manufacturing dental applications. But before I start, Corey, do you want to say good day?
Hello, everybody. Thank you so much for joining. Just so everybody knows, it is 4 a.m. for Graham right now. He's actually in Australia, in Sydney, and so it's. I just want to say a special thank you to Graham for getting up so early and joining us today. It's a privilege to have you in our presence.
You're too kind, Corey. It's good to be here. So just a little bit about Asiga as a company. We formed a number of years ago now, and we launched our first product in 2011. And that was it was a revolutionary product in its day. We had a very clear goal that we wanted to design and manufacture an affordable but a repeatable 3D printer for digital manufacturing applications. So 3D printer used to produce actual parts, and there's some industries, and dentistry is one of those, where you use 3D printing to produce an actual product. Prior to that, 3D printers, they were called a different thing then, but they were used primarily for validating a design. But we had a real focus on making products for digital manufacturing. And printers on the market then, back in 2007, when we actually formed, they were inconsistent. And I think today there are a number of systems that still have a level of inconsistency. And we really wanted to do better. And this image is actually a relevant. It's relevant to Asiga, but I'll come back to that shortly. We wanted to do better, so we decided to take on all engineering disciplines and have them under one roof. We wanted control. We wanted to ensure that what we were delivering to the market was of a level of quality that we could maintain. And we could also introduce new technology features and new hardware features in our products. Our first product that we launched was the first DLP 3D printer to use an ultraviolet LED. And it was also the first 3D printer to print on a film membrane. And even still today, we still design all of our products in Sydney. All 3D printers are manufactured in Sydney. And we've also we develop all of our own materials, and all of our bottling lines are in the same factory. And we have a full software division where we do all of our software programming. And we focus on some key points. So the number one key factor with our solution is accuracy. We need to maintain a level of accuracy in our systems, but directly alongside that is the repeatability of that. Those are the two. The repeatability in 3D printing is one of the biggest challenges. Now, I think every 3D printer on the market today has the capability of producing parts accurately. But to do it consistently is very difficult, and we really do believe we've overcome this with our technologies that I'll come to shortly. The third aspect is speed. So our systems use technologies that allow them to maintain a certain level of speed, so we can deliver parts to market quickly, and we're big advocates for remaining open. Excuse me. With the development in materials today, we've got a solid and stable 3D printing solution, the hardware, and our open technology, our open material architecture allows for using the latest materials that come to market, and we'll go over that shortly. But those are the key focus points for our company. The reason I showed you the image earlier of the young girl with a hearing aid is that we're the market leader for manufacturing hearing aids globally. We're the market leading 3D printer used by the largest audio laboratories. And we're very proud of that. So when we began in 2007, the biggest audience for 3D printing was the jewelry sector. And we quickly moved into audiology back in 2012, 2013. And we're today one of the leading products in that. Well, we are the leading 3D printer in that sector. We're still very much part of the jewelry sector as well. So we have a focus on the jewelry industry. And our leading market today is dentistry. The reason I'm showing you these markets is because our products are pretty versatile in that they can be used across multiple industries and multiple applications. We have certain models that are more suited to certain applications, but you can use that for a dental machine. You can also use that for audiology, for example. And part of that industry spread, there are other industries that fall under that are in our target. We have a number of systems now globally that we're supporting, and we're doing that across our offices. So our head office in Australia, in Sydney. We have a European centre, which is our applications hub in Germany. And we are opening an office in the US, which will become the training center for North America. Corey, over to you.
All right. So thank you, Graham, for that history lesson of Asiga. It's pretty amazing to see where we came from and where we are today. And so when we look at the Asiga line of 3D printers, one of the most important aspects of Asiga is that we use DLP technology for our 3D printers. And so what is DLP technology and what else is there in the industry? And so DLP actually stands for digital light processing. And in DLP 3D printing, we actually can use a DLP projector, a projector engine, and cure every layer all at once, one layer at a time. And it's the most accurate way to actually create a structure in 3D printing using the resin-based format. So here in a second, I'm actually going to show, we actually can show exactly how the 3D printing process works. And so when we're looking at a DLP style 3D printer, we actually have a build platform, and that build platform is going to move down into the liquid resin vat. From there, there's a projector that is actually underneath the resin vat, and it's going to expose a projected image, curing a layer of resin. The build plate will then separate from the resin tray, reapproach, and it will then cure the next layer until the objects are completely formed. And so it's layer by layer by layer, additively creating the structure that we want to print. And when we're looking at this, also keep in mind that a 3D printer is just the output side, and it has to start at some place, and that some place is going to be at the intraoral scanner or the desktop scanner. You'll have to have a CAD software, and now the 3D printer fits in on that output engine itself. So some of the benefits for actually using a DLP technology is that it's extremely fast. It's one of the fastest forms of 3D printing in the industry today. And the reason why, once again, is it can actually expose the whole layer, the full layer, all at once in a matter of 2 seconds or a second itself, and it cures the whole layer. It doesn't have to trace on the object to actually create it. From there, we even have XY stability with the actual projector. And so if we look at a projector and how it operates, it's projecting thousands of pixels to create an image. And with a high quality DLP projector, like the ones that we actually use to fabricate our 3D printers, we actually have a very strong XY stability across the whole imaging plane, giving us that repeatability success for our 3D prints. From there, we also gain access to different UV options as well. And so we're not just limited to 405 or 385 or 365 nanometer light sources. We actually can tap into all three depending on which version of printer you purchase. And that actually gives us a wider range of chemistries we get to play with our 3D printers. And we'll go over it a little bit further in about what UV option is best for dentistry. But what we'll see for different unique chemistries, maybe in industrial applications, they may need to be in a stronger light wavelength at 365 nanometers. Or if we go into jewelry, they may need a different surface finish that maybe requires a 405 wavelength, for example. So from here, we actually have an excellent set of slides that Graham's going to go through that covers the Asiga monitoring technologies that really make us that cut above the competition.
So what makes Asiga unique? Well, I couldn't help but put the fact that we're manufactured in Australia there, and share an example of a slice of Australia with everybody who's watching. But the things that make us yeah, that's the view outside of my office window. It's not really. This looks more like my view. So with regards to the technologies that make Asiga different, it's so important that Corey's just explained that the process of the DLP layering technology. Now, that's forming layers one on top of the next. So a 3D printed object is a stack of layers, a stack of images that are formed one on top of the other. Now, a critical part of making sure that a 3D printed object is fabricated accurately is to ensure that every one of those layers is formed correctly, so that they're formed to the correct thickness and the correct size. You know, when you dig into it, it makes total sense. It makes sense, but the reality is that doesn't happen with lots of printers on the market. The actual formation of those layers, there are estimations, there are assumptions made during that process, and we don't feel that assumptions or estimations are the correct way to go, especially in manufacturing applications and specifically in medical. So for audiology it just can't happen, and in dentistry, and we all know the level of accuracy that's required for dentistry for fit and compliance with the patient. It's vital that the layers are formed accurately. So the number one technology that sets Asiga apart is our SPS technology, our smart positioning system. And that technology that detects the build platform position. So as we approach for each layer, our SPS technology is detecting whether that platform has actually reached the position that it needs to get to before the projector projects that image and cures the next layer. Every other system on the market today assumes that position. They drive the platform down to the intended position, to the target, and then they'll wait. They'll wait a number of seconds. And that waiting time is to allow for the printer to settle and the resin to stop flowing between the gap between the platform and the previous layer. Now, that waiting time is inconsistent because there are lots of factors that can affect that waiting time. One of those is the viscosity of the material, so how thick or how easily the material will flow. So the more viscous the material, the thicker the material, the more gooey it is, the longer the waiting time required. And that viscosity will change throughout a day, depending on the temperature of the resin in the machine. So if you have in your laboratory or in your office, if you've got you may in the morning, the temperature of the office may be very different to what it is in the afternoon. So that will have an impact on the resin. The other element is the cross-sectional area of each layer. So the larger the cross-sectional area, the more time that it would take to settle. So having a set waiting time is just not accurate. It's not an accurate factor. So we use our SPS, which detects the actual position of the platform. And that ensures that every layer is formed to the correct thickness. And this is critical. This is a 3D printer produces parts layer by layer. So if you can't achieve a consistently accurate layer thickness throughout an object, you will not achieve a consistently accurate 3D print. That's just fact. You can't avoid that. So this is a technology that is proprietary to Asiga. There's no other printer that we know of on the market that actually detects platform positioning. It's all around an estimation. So they make an assumed or an assumption that their platform has made the target position in the Z-axis.
Yep.
And this technology will show you, this video, sorry, will show you how that's achieved. So this is on our Pro 4K. It's the same technology that's used on our Max UV. So here you can see the smart positioning system encoders. We have a build platform, we have a resin vat, and we've got a projector. So as we approach, those sensors are engaged. They're reading printer deflection and material flow. And as soon as everything is recovered from that approach, a signal sent to the projector to project that image. And you can imagine you've got two fairly large plates coming together, and they're squeezing out thick resin to a thickness of 50 microns or 10 microns, whatever layer thickness you want to print at. There's a tremendous amount of force that's in play when that approach is happening. So those sensors are critical to make sure that each layer is formed to the correct thickness.
That's something that I really appreciate about the science behind Asiga. They've always, or we have always been driven on forming the proper layer thickness. It goes back to our slide and separate technology that we had in our Picos and our original Pro printers itself. And this concept, and it's been proven by Asiga, that this is what creates the most accurate form of can achieve from a 3D printer itself.
Yeah, and it's one of those technologies that we feel almost forgotten. It's the principle that's almost forgotten, that to 3D print something accurately, you need to ensure that you need to know where your build platform is. Yeah. You can't just drive that down on a Z-axis, and because as you approach the resin and you're trying to squeeze resin out from a very thin gap between the platform and its target, there's a lot of deflection that occurs. There's a lot of force back on that platform, which creates the printer it causes deflection in the printer. And if you don't know whether you've recovered from that deflection or that the resin has stopped flowing, you'll start curing the material when the printer's not ready. So you might start curing the resin whilst the resin's still flowing, or you may be producing a wedge-shaped layer because the platform hasn't quite reached that target. So right. We don't assume Z positioning. We work off actual Z positioning. Now, the second thing that's part of that layering process is then curing the material. So we've achieved the correct build platform position with our SPS technology. Now we just need to make sure that we cure that material for the correct amount of time. Now, all materials are different. They all require different curing times, and it will also depend on the layer thickness that you're printing at. So the power of the LED or the cure time is critical. So you want to make sure that you're then curing that material for the correct amount of time. And that cure time is based on the layer thickness that you're printing at and the available power that you have from the LED. Now, in all Asiga systems, and ever since our first Pico systems back in 2011, we've had an internal radiometer. And that radiometer reads the LED power for the life of the product, and it auto calibrates. So as the LED power reduces over time, which it will, we can't avoid that. No LED will maintain the same consistent power for the life of the LED. Fortunately for us, LEDs last tens of thousands of hours of on time, which is fantastic. But as that LED decreases over time, we need to make sure that we're aware of that, and that's what our internal radiometer does. It will detect a drop in power, and we will automatically increase curing time to compensate. So without having an internal radiometer, as that LED reduces over time, if you're not calibrating externally, which is then a manual process, you don't actually know that you're dosing the material for the correct amount of cure time to cure that resin effectively. So we do all of that behind the scenes internally. All of our end users don't need to calibrate the radiometer. That's set for the life of the product.
It's all performed automatically, like Graham was saying. In fact, I was just at a jewelry convention a couple weeks ago, and that was one of our first, industries that we went into. And I had a couple clients actually come up to me that are still using the very first Pico that we released in 2011, saying that they're still using it in their production facility. And they're looking at our new Max X for the jewelry line, and they asked us like, well, should we upgrade? Should we get a new one? And I had to ask them. I was like, well, is your printer still working? And they're like, yeah, we're still using it every day. I was like, well, keep chugging along with it, because it's a phenomenal machine. And that internal radiometer is what is actually keeping their printers in use and in function, and that's what keeps all of our printers alive over the life of the printer. And to my knowledge, there's no printer on the market that can compete against us in that stand and can state that they have a printer since 2011 still operating using in a production environment.
Yeah, I sort of forget about, as you go through the years, and when you're developing new materials, new 3D printers, sorry, you sort of forget about you don't forget about your past, but the early systems like the Picos and the Pro 1 and the Pro 2, you sort of forget about those, and because you're focused on the latest products that you're selling today. But there are many of those early printers still in the market. Jewelry, and there's lots of them. So the jewelry industry, before dentistry really became popular for 3D printing a few years ago, the jewelry market was the largest user base of 3D printers globally. So when we launched in 2011, they were the largest user base of 3D printers globally, and they use 3D printers to manufacture jewelry. They design jewelry appliances like dental techs and dental clinics will design dental appliances.
Yeah.
So it's really nice. I've had the same thing to me specifically at that show. The show's JCK, and it's held every year in Las Vegas, and it's really good to meet customers that have still got some of the earlier systems. But it's true, this is one of those technologies that has given them that production consistency over the years. So all Asiga systems use industrial grade LEDs, like high powered LEDs. And over time, the LEDs have increased in power. The technology's got better and better. We don't manufacture the LED itself, but we bring in industrial grade LEDs that provide a power that we actually have to limit on our systems today, because materials typically don't have a lot of materials, they don't like too much power. So we actually we restrict the power on our systems so that we get optimal curing. But for medical applications specifically, Corey mentioned that we've got a range of different LED wavelengths. For medical applications, we really recommend our 385 nanometer LEDs, so UV LEDs. It's an invisible wavelength. It's a wavelength that we cannot see. So that allows us to produce water clear materials, because we don't have photo initiators in there that need to be visible, like a 405 nanometer system. That's a visible light. So they will never be able to produce a water clear material. But 385 is crucial for producing really accurate, or curing really accurately. So materials respond a lot faster, so you get much more precision in the XY, and a much more controlled Z layer cure. So we recommend our UV LEDs for all medical applications. We also recommend small pixels. So across all of our printers for dentistry, we say a pixel size sub 65 microns is ideal. So that covers that just means that printer will cover all dental applications from restorative through to ortho or prosthetics.
Yeah.
So the smaller the pixel, the better. And as you reduce pixel size, you reduce image size. So we've picked a good combination between pixel size and available build area or print size to ensure that you can produce a good volume of parts across all of our printers that we present for dentistry, and we'll come to those shortly. And all of our material profiles that we have in our material library online, they're all customized to each material because every material performs differently. You can't use one curing profile for a number of different materials because they'll all have different XY offsets, they'll all shrink and scale differently. And part of our material profile, we generate all of our support settings, so our support profiles. So some materials are very strong whilst they're being printed, so need fewer supports, and some might be rubbery materials that might need a bit more structure in the supports. So the setup of the material files are incredibly important, and precise material curing is a factor to ensure that you get what you want out of a 3D printer and you get that consistently. So that screen there is really a snapshot of a combination of all of our features that enable us to produce an accurate print, but also consistently. And the only thing that sits alongside that is just robust engineering and just a quality construction. So we spend a lot of time in engineering in Sydney, developing, mechanisms and assemblies that are incredibly rigid. They're incredibly robust. They can last the test of time. We know our systems go into applications or into some companies where they're very well looked after. We also know that our systems go into companies and they get treated as a lot of manufacturers would treat their equipment. They get pushed and they get tested, and it's important that printers can maintain that throughout the life of the product. And the challenge ultimately is to 3D print accurate dental models with removable dies. That's really there's a number of dental applications, but if you can produce models consistently that have removable dies, you've cracked it. Because that's probably one of the most demanding applications where accuracy plays a huge role. And we're very proud of the output of our systems today. So these were printed on our Pro 4K 80 UV in our DentaModel material. So if you're using the presets out of 3Shape or Exocad softwares, they're available on the Asiga website. You get really nice offsets and fitting of dies, removable dies on dental models. And so the result is a repeatable and accurate output, and for patient safety and quality assurance. And when we validated this with 3Shape as part of our integration with their Implant Studio software, that highlighted that 93% of data points were within 50 microns of the original CAD file, and they hadn't seen that prior. That was pretty staggering. Normally, the data points were classified within 100 microns. So we were really pleased at that. That was a validation that we knew that our printers produce parts accurately, but it's only until you take in a 3D scan of the 3D printed part and offer that up to the original data. It's only then that you see what kind of accuracy you're getting.
It's actually quite phenomenal. I mean, like Graham said, most as 3Shape was going through their testing, most printers, they're looking at a 93% within 100 microns, and that's where most printer manufacturers stop at. And so that's that's once again going back to Asiga, it's just not good enough, and we're looking for great, and we're looking for perfect. And something else, when Graham was talking about our monitoring technologies, and I can't say this enough, but we produce the smartest printer. I mean, and we absolutely do, and I believe it wholeheartedly that our machines are so intelligent and so smart that we're able to produce, the most accurate structures with very little effort applied to it because of the intelligence that are built in. So looking forward, let's take just a quick peek at our 3D printer overview of what we'll actually have in the dental industry. And so we currently have two main printers that are really the thoroughbreds for Asiga in 3D printing and dentistry. And so that's our Asiga MAX UV. And so that's our smaller compact desktop system. And so if you're in a compact space, or if you're in that smaller to medium laboratory, or if you're in that clinical laboratory, even large laboratories still actually go straight for the Max just because of the speed and durability of the machine itself. But it is nice and compact. We do have our large high volume system as well. And so we do also have our Pro 4K 80. And that is the larger footprint printer that has a larger print volume. And we're actually going to see that here in a moment on what that actually looks like. And so let's take a look at it. Oh, go ahead.
Sorry, Corey. I was just going to say that you'll notice that alongside the names of these systems, you can see the UV. That specifically points that's the system that will house our 385 nanometer LED, so the UV LED. We have non-UV systems of these two models, but for dentistry, we strongly recommend our UV systems.
Absolutely, that is crucial. Thank you for pulling me back in there, Graham. The ultraviolet, when you're at that point of making the purchase for an Asiga system, make sure that you state that you're looking for the Asiga MAX UV. Henry Schein already knows, they already have it programmed in their system, but while you're looking and shopping at it, the ultraviolet UV versions are the ones specific for dentistry, and those are what will get you the widest range of possible materials in dental also. Let's take a look at it from the print sizes and the X and Y dimension. And so the X and Y dimension, if you look at the Asiga Max, it's 119 by 67 millimeters. It's about the same size as your cell phone screen. So if you look at your cell phone screen, it's very similar to that footprint. And we can see that we can easily fit 3 full arch models that do not have an articulator base on the heels of them. And then if we go to our Pro 4K 80, it's actually a little bit greater than 3 times the size. And we can actually fit, I believe there's 11 models on that build space there. And that actual build space for the Pro 4K 80 UV is 217 by 122 millimeters. It's just a little bit greater than actually 3 build plates of the Max itself. It's a phenomenal machine. It is the larger capacity machine. From here, let's go ahead and just take a look at the actual output and speed and performance of each machine. And so the Asiga MAX UV, when we're looking at it, we can easily print 3 of those full arch models in 100 micron layers in about 20 minutes. Now this is all based off of height, and these models were specifically designed for aligner therapy or for vacuum forming. So take that into consideration if you're printing a implant model or a crown and bridge model with removable die. Depending on how it's trimmed, that can also change the actual print speed itself because it's a taller structure. Remember, we're creating it layer by layer. If we were to go down to 50 micron layers, which is what we recommend for restorative work, that will actually be about 40 minutes for these exact models, and you can still do the 2 to 3 models in that same amount of time. When we go to standing up vertically itself, we can easily fit 6 to 8 models, and in 100 micron layers, that's about 50 minutes. Now, you may be asking yourself, what if why do I want to print in 50 microns? Why do I want to print in 100 micron layers? Well, it is, first off, completely customizable on the Asiga system. You can actually print down to 1 micron layers if you absolutely wanted to. It would take a little bit longer, but you could achieve it. And the reason why is because we use a high quality servo motor for our Z axes. But when we look at the practicality of 3D printing, our restorative work, so fixed prosthetic, we're going to want to print that at about 50 micron layers. And then anything for ortho or removable prosthetics, we're going to go with 100 micron layers. And the reason why is when we're going with fixed, we need that great surface quality and that very precise surface, and we can go down to 50 microns. For orthodontic and removable applications, you have a little bit of leeway there for the surface quality, and you may not want to sacrifice the print time for that type of application. And so printing at 100 micron layers is okay. You still have the ability to print 50 micron layers though if you absolutely want to. So we actually have on that snapshot, actually, because dentures are extremely hot right now in digital dentistry. Graham, I wanted to ask you, right there we see 7 denture bases on the build plate, and that's on the Asiga MAX, everybody. What, do you know what that actually took to print roughly for
The
time?
build time,
Yeah,
it took around 1 hour.
really? Okay, that's 100 micron layers, I would imagine, correct?
Yeah,
That's
yeah,
phenomenal. So 1 hour, 7 dentures, 7 denture bases. Now you still have to print the teeth, and so you would set up the printer with a second job and print the teeth. And that would still probably take actually, because you'd print those most likely horizontal to the build plate, or you could if you wanted to. You could probably pump those out in about 30 minutes, which is phenomenal. All right, sorry,
yeah.
I had to put you on the spot there.
No, that's good. It's a good point. I remember when we were a few years ago at, I think it was IDS in 2017, we had a material manufacturer releasing a material as part of our open system. And they were trying to optimize print speed and the Max specifically, and they got that they were printing um, they were printing denture bases in an hour, and so the print speed for the total height is around 60 millimeters an hour, something like that.
Yeah.
And back to the material curing on that technology page that I went through, some materials, react more quickly, so they might be a bit more sensitive to the light, so they take less energy to cure, so the cure times is shorter, print time is shorter as a consequence. So there are some materials that will also play a role in the speed of the printer. So these took around an hour. There are materials that will print much faster than some, but that's still it's a phenomenal output on a desktop system.
Yeah, it really is.
Oops,
Oh,
wrong
no.
way. We could go back to the Max UV if you want, Corey, but we'll go to the Pro 4K.
I mean, the Max UV, the Max is a phenomenal machine. And so we released the Max in 2017, correct, Graham? And so in 2017, we released the Max. And with that, we're actually able to test our new technology, that smart positioning system. And with that, actually, we're able to create the Asiga Max's bigger brother, the Pro 4K 80. And so this build plate, we can see it's actually about 3 times the size of it. We can print 9 to 11 models, horseshoe models, like we see on the build plate there, in 100 micron layers in 20 minutes. And if we were to go to 50 micron layers, we can actually produce them in about 40 minutes in time. Now, a lot of people ask the question, well, how can it print the same speed, and why is the Max and the Pro 4K at the same speed? How is that possible when you're printing more on the Pro 4K? And remember, the reason why is because we use DLP technology. And so that DLP technology, we're exposing the whole layer all at once and creating the structure. So it doesn't matter how large the build plate is, we're going to expose that whole imaging plane with the same amount of time or same amount of energy of light to cure that layer, no matter the structures or the amount of structures on there. If we were to actually stick these bad boys vertically, excuse my language there for a second, but it is phenomenal because it is 20 to 26 models we can fit on the build plate, 100 micron layers, and we can print them in 50 minutes. And so if you're looking for maybe using your printer even in an orthodontic application for doing any sort of vacuum forming, you can really optimize the printer in that indication line. The same recommended layer thicknesses for the Pro 4K and the Max, that's going to stay the same. And so if you're doing anything restorative, we recommend 50 micron layers. Anything that's removable, prosthetic, or orthodontics, we're going to recommend 100 micron layers. And it is controllable just like the Max, where you can even go down to 1 micron layers if you absolutely wanted to. Or you could even go up to 200 or 250. You can even program in and type in 32 micron layers, for example, if you absolutely wanted to. It is controllable down to 1 micron layers due to our servo motors.
That's right. And just to add there, those presets of 50 microns and 100 microns are in the software, so you can select them from a drop-down menu. But you can, like Corey said, just type in a value, and then the software will look up from a curing table what cure time that it would require for, say, 32 microns or 57 microns or 43 microns, whatever that number is, you'll get optimal curing.
Yeah. So here in a second, we're going to see, the absolute output when we're looking at digital dentures. So that there's a total of 15 denture bases on there, and this once again still took that hour time. And so when we're comparing it, you know, when you're looking at what your output needs are, you can actually see the difference in the amount of output you can between the two printers. So up next, we actually have what really makes the Pro 4K unique is 4K technology. And so we actually have a 4K mode that is enabled automatically with the printer. And it is a feature that you don't have to turn on, and it comes standard on every single Asiga Pro 4K. So how this works, it actually has this pixel shift technology. And if you're familiar with 4K technology, it's also known as a term called wobulation. I thought this was something that the geniuses at Asiga made up. I thought our engineers, you know, pulled out the dictionary and let's take two words and put them together. But no, wobulation is true terminology. This is an actual term that is used for projection methods. And so what we found with this technology, it actually increases the quality and the accuracy of the part we're printing. And so on the screen right now, you can actually see two eyes. They're actually the same image. One that is unwobulated, you can see it's granulated and pixelated. And so you can actually see the visible pixels that are creating the structure, the native pixels. And when we're looking at precision, if we actually reduce the pixel size, make a tighter or denser pixel mesh, we can see that the image is truer to what we're trying to project. And so when we turn on wobulation, the surface quality and the accuracy is so much greater to what we're trying to achieve. So now we have actual two live images of, this is printed in our dental model, both 50 micron layers, and one using the native mode and one using the 4K mode. And so we can see the surface quality on the left, it's kind of granulated, and it's a little rougher, I guess you could say. It's not as accurate or true to what we're trying to produce. And then with 4K mode on, it is, I mean, honestly, it's probably the smoothest model I've seen out of any 3D printer, and the surface quality is phenomenal. I call it butter smooth because it is just about like that. And you can see with the 4K mode on, it reduces any sort of pixelation. It's going to increase the precision, and it's going to be the truest form to what your doctors would see as a stone model. And remember, that's what we're trying to achieve with 3D printing, is how close can we get to the real thing. I don't know
Thanks,
if
Corey.
I didn't know if you want to add anything else on that, Graham, but it's
See,
honestly it's astounding.
yeah, when we launched the Pro 4K, we knew that we had that mode available, but we had to obviously go through our validations. And you don't really know what you're going to get until you've assembled all those parts that you've spent hours and hours on a computer design software. But then when you get all of those bits come together and they get assembled, and you actually see for the first time the output of the printer, we were amazed. We really were. So the 4K mode is, yeah, it's incredible.
Yeah.
And you can see that on the native mode, you can see they almost look like layers on the surface of the crown there. we call that digitization. So that's actually the edge of every pixel as they're layered up on top of each other. So by switching on 4K mode and reducing that pixel size, you get much less of that digitization, to the point where, I love it, Corey, butter smooth.
Yeah, it really is, and I'll see so many complaints from our competitors where users are trying to, you know, they'll share photos of their prints and they're like, how do I get rid of this surface quality? It's unfortunately you're stuck with that with those printers, but when you actually advance to the Pro 4K, you're actually able to step into the smoothest models you could possibly get.
Yeah, so that's an example of pixel size that we covered earlier. The smaller the pixel, the better, the sharper the detail, the better the definition. And that's an example. If you've got an 80 micron pixel, if that's sort of what you're going to get. So the smaller you go, the better the output. But 4K mode just helps soften further that digitization. So yeah, thanks for going through that, Corey. Now, to one of the hot areas of just 3D printing in general. It's not just dentistry. This is across the board. We in 3D printing today, materials are just unlocking new applications. Where 3D printing have never been used to manufacture components before because materials have not been available, they're now being used because those resins are on the market, and it's exactly the same for dentistry. We gauge sort of the developments of the industry at the big trade show in Germany. Actually, IDS it's every 2 years. It's actually next week, so we'll be there for anybody who's able to make their way over to Germany. Come by our booth. But when 3D printing in dentistry has been around for a long time. In audiology, it's been around for 30 years. 3D printing hearing aids they've been making hearing aids via 3D printing technologies for 30 years. Dentistry and 3D printing, it was normally the big labs, but now that the cost of the technology has come down, it's reachable by more people. But also there's more materials available. So you can actually print nearly all dental applications or dental appliances now because there's a material for it. And that's really where we're seeing the biggest growth in material development. So we are across multiple industries, but dentistry and the number of material manufacturers, or the number of dental manufacturers that make dental materials, you just have to look around your lab or your office and you'll see there's lots of brands there. Most have an interest in 3D printing. So it just unlocks applications. And it's applications galore for dentistry. And we're really proud to, at Asiga, we develop all of our own materials. We've got a line of resins that we design and manufacture ourselves in Sydney. And we push equally our open platform. So our open material system is the most open system on the market. We have over 450 optimized and validated material profiles available now. And that's just awesome for us, because whenever we develop, we want our customers just to get the best experience out of our 3D printers. So as far as our continual value add for our customers, as a new material comes to market, they get the compatibility for that. So as new materials come out, all of our existing users can just hop into the material library, which is what you can see on the screen here. That is how our material library looks online and inside all of our Asiga end user accounts. You basically click on the material manufacturer's logo, and you will see the list of available curing profiles or material profiles. You basically select the material that you want to print with, and away you go. There's over 450 validated materials now, which it still amazes me. And we put a lot of our European office is our applications hub. They work with all of the leading material manufacturers, and they're all working on the latest dental materials. So with an Asiga system, we say that you really are future-proofing your investment. And today, that is a snapshot of the material manufacturers that are specifically manufacturing dental materials. And it's growing. There are new material manufacturers that we will be announcing next week at IDS. And it's growing all the time. There are new material profiles going in there weekly. As I said, our European office, they work that one of their main objectives is to build material profiles with these material manufacturers. So they're working on material profiles every day of the week, and we put investment into that because we want to make sure that our users get the best out of our systems from a materials perspective, because that's where the development is now. And this video will just show you how easy it is to get hold of a new material profile. So this is our software called Composer. You basically load the build properties, you click onto the material library, and that takes you into your account online. You go into the material library, and this was recorded just a few days ago, actually. So this is alive. This is reflective of what's there today. So you find the material manufacturer that you want to get the material for. In this case, it's Keystone, and there you can see all the available data for Keystone materials. So you select the material that you want. So that's the Keysplint hard resin. We've got the Keysplint soft profiles in there, along with lots of other materials. You basically download that profile, you drag that over into your open material folder in your Composer, where Composer's installed. Then it automatically shows up in your material drop-down list. And then sorry, Corey.
I was going to say, how easy can it get? I mean, that's about as simple as it is to be able to reach any resin you want from any manufacturer in a matter of minutes.
Yeah, and you're not picking a profile that you've used for a model material, for example. You're picking the profile that has been custom built for that particular material chemistry. So you will achieve optimized printing. So that's plug and play, really. You don't need to do anything else other than send that job to the printer. So the material libraries, it's a really important factor for Asiga, and we will continue to invest our resources into that to make sure that all of our users get the best out of our products. We have a number of user features. I'm mindful that we're coming up to time here, so we're nearly at the end of these slides. But as part of our printer development, and I'll just say this now because it's probably a good time, that we use a single point calibration process on our printers today. When we launched, we had a 4-point calibration where you basically just loosen 4 screws. But when we started to work with the audiology sector back in 2013, we received lots of input from them around that, and also our jewelry customers around what they would like to see in our printers. The key point for the audio sector is that in their laboratories globally, they'll be one of the large manufacturers. They have a head office, and then they have satellite production centers all around the world, and the 3D printers are operated by machine operators. It's not the person designing, it's somebody just running the printers. So to make sure that they can interact with that printer really easily and calibrate and operate in a way that it was consistent across all of those machine operators, and also for just an individual user that is just looking for a printer for themselves, calibration is one of those factors that we wanted to make just super simple. So we have a calibration, we call it single point calibration. That's just the process to level the build platform or to zero the build platform. So we know that the platform is calibrated to the printer, the position. Now that's periodic. You do that as and when you really need to. We recommend every 20 to 30 builds, but some users don't calibrate because the systems are so robust that unless you're really heavy-handed with the printer, it's likely to hold on to that calibration long term. So we have a single point calibration. We have the fastest material changeover of any product on the market. You can switch between, say, a denture-based material and a tooth material in around 15 seconds. And this shows how to do this on the Pro 4K. It's a very similar principle for the Max UV. So we have a locking mechanism for the build tray or the vat. You take that material tray out and you put that into its storage container, and then you take the next material that you want to print with, put it in the machine, and lock the tray. And all you need to do aside from that is make sure that your build platform is cleaned with isopropanol, IPA, just so you don't have any cross-contamination of materials. That's how simple it is. It's a really fast process. We have an environmental control on all of our printers, which basically means there's a heating element that's maintained and regulated on the machines. So we can warm materials or keep materials at a set point temperature whilst they're being printed. Some materials require temperature to process, but just by having a consistency, a lot of materials you don't necessarily need to use our heater or our environmental control, but it just as you warm materials, it reduces viscosity. You can get better performance out of the printer in that it prints faster. And we have a remote control on all of our systems, so you can access the printer via a web interface to manage your print jobs. All of our systems come with Asiga Composer. That's a software that we've written, and we continue to add features to that in-house. Composer is compatible across Windows, Mac, and Linux, and it's you have unlimited installs. So if you've got a number of PCs or Macs that you want to have installations on, you can install that on any number of computers, and they can all read off a central location for all of your material profiles. So you can have multiple installations, and all updates are included for free.
Not only on that, I want to add in that not only can you have as many installations on as many computers as you want, but there's also you can connect as many printers to one installation if you want to as well. So it's not like you have to have one software for one printer or one software per printer. You can actually run as many printers as you want, as long as they're connected through the network and readable by the software. You'll be able to address any printer at any location in your facility.
And just another point as well, you can also load multiple builds in at the same time. So you can see on the screenshot there's a tab with an X next to it. You can have multiple tabs across that user interface. So you can be generating multiple builds at the same time.
Yeah, absolutely. So something that really, we've talked about how great our printers are, and we've talked about, our open material system, but probably one of the most, probably the most important aspect that anybody shopping for a 3D printer should be investigating is what is the technical support like and how long does it last for? And we actually offer unlimited lifetime technical support for all of our 3D printers and software that we sell, and it's completely free. And so that's the most beautiful thing about it, and it's accessible 24/7. So 24 hours a day, 7 days a week, you can access our online technical support portal and log in support tickets, create support tickets, even access the training database as well, training videos, and it's all located on our website, which is phenomenal. It's actually a really nice intuitive chat platform. So as you can see on the screen, it looks like a customer went ahead and put in, hey, I'd like to understand some information about the printer itself. And you'll actually have a chat dialogue recording every single conversation aspect of the issue you're having. And it's accessible later as well. So if you had to maybe jog your memory on how you came across a question or what the answer to the question is, you can always access it later. And probably the most exciting thing for me, and probably Graham as well, but we actually have because we have 3 locations, we actually have almost 24-hour support running all the time. And so with us being located in the US, we're going to have the US time zone covered, and then over in Germany we have the wee hours of the North America covered, but also in Europe it's covered in that time zone, and also in Australia we're working while everybody's sleeping. And so we are literally working 24 hours a day on our technical team, which is to my knowledge one of the only 3D printer companies that is offering a service like this, which is phenomenal. So we have a testimonial. We did find out that the sound, I don't think it will pick up that well. So hopefully it does. If you want to watch the video again, and I highly recommend that you do. In fact, I've probably watched this video probably 15 times at least. And there's an awesome, the first sentence is I think, and Graham pointed that out to me when I first started at Asiga. But we'll go ahead and watch our testimonial from Race Dental Lab. This is Australia's largest dental lab and probably one of the larger dental labs in the world.
This might be a piece of resin, but it's ultimately someone's mouth. So getting it right and looking after that patient is super important to us. We're an 84-year-old business. We've historically manufactured for dentists across Australia. We're the biggest lab in Australia and probably one of the biggest in the Southern Hemisphere. A patient will see his or her dentist who will take an impression. The impression is taken digitally. That file is received in the lab. We manufacture the restoration by reductive technology or milled, and the model is 3D printed, and that's where we get our accuracy and our consistency from. The fit of the die into the model needs to be perfect. No movement. We're talking microns now, thousandths of a millimeter. We went through an enormous amount of research and development when we chose printers. We've had different types of printers over the years. We worked them pretty hard, and we saw a lot of deterioration over time. When Asiga came along, we realized that we found an excellent product that didn't deteriorate. For us, it was a no-brainer to take on the Asiga product. We've been running the Max UV for some time now, but we've just taken on the Pro 4K. It's got a larger platform and faster results. I was surprised to see it's an Australian-made product. Their technical support is awesome, although we don't see a lot of it because they're reliable machines. We've got maybe 15 or 16 across Australia, New Zealand, and Singapore, and we're planning on taking on more.
And so that first line of it may just be a piece of resin, but it's ultimately somebody's mouth. I mean, it just resonates so loud in the fact that, you know, we're producing products that are changing people's lives, and it's taking in the highest level of patient and quality care that we can come to. And so it's you know, it's more than just a printer. It's more than just resin. It's somebody's life that we're changing with this equipment. So from here, just so everybody knows, we are located in Ann Arbor, Michigan. And so as Graham mentioned, we're actually in process of setting up our location in North America. And so once we're up and running, we'll be excited to provide announcements, and we'll be doing webinars live from our training studios. And so super excited to get that rolling. If you guys ever have any questions, you want to reach out directly to Asiga, you can reach out to us at info@asiga.com, and please go to our website, www.asiga.com, and you can view all of our printer lineups, all of our materials, and all of our partners as well that we work with on the resin manufacturing side. So we're going to go ahead and turn it over to Henry Schein. If you guys have any questions, we're going to go ahead and do a Q&A session. And then from there, once again, we can't thank you enough for taking your time out of your day and joining us at Asiga.
Thank you so much, Graham and Corey. We do have a couple of questions here. The first one is, how fast are the printers?
Lightning speed is what I like to say. Now it's Graham actually touched on it just a little bit earlier. So the speed is going to be dependent on the height of the object and the material you're using and the layer thickness you're printing in. But a general speed that we have found in 100 micron layers, you can print about 60 millimeters in an hour, depending on the resin. Each resin is going to be a little bit different, but it's going to be close to that hour, 60 millimeters per hour, which is really quick.
Great. The next one is, what if I wanted to use a material outside the validated list?
So that's a great question. So outside the validated list, because we are completely open, we actually have step-by-step documentation that allows users to go through and actually create their own profiles. And remember, there is free lifetime technical support. And so if there's any sort of questions or help that is needed along the way, we'll be there to help you out.
And we have one more. They want to know when is software updates available? Is it annual or biannually?
So that software updates are released as and when we feel we need to share a new feature. So they occur periodically all through the year. Yeah, so I think one of the big announcements or the big software releases was a couple of years ago where we increased the speed of our systems by 30%. We had some features released. There's been a few software releases since then. But yeah, basically when there are new features to share, and we take software seriously, and we have some new things in the pipeline which we're pretty excited about. So there'll be a pretty major software update coming.
And how will the users be notified about the updates?
So all of our customers receive a pop-up notice in Asiga Composer. So the software will just prompt them that the new software is available, and they can choose to update or remain on the existing version. We do recommend customers do update, and then they log into their Asiga account and download the software. So all of our end users, when they receive an Asiga printer, they register an account at asiga.com, and then that allows them to register their product. Once their product's registered, it immediately opens up access to our material library online, our support ticketing system, and also all of our software and firmware downloads. So they basically have control over what setup they would like to use on their systems.
Okay, we have another. It says, I bought a used Asiga printer. Will the software work on it?
Yeah. Yeah, if somebody's bought a used printer, as long as the registration's been transferred over to them, which is free, we can help them do that. Then they can access software in their Asiga account online. If they're struggling to do that, then please send an email through to info@asiga.com.
And he also wants to know regarding material selection as well, the software will work?
Absolutely. Yeah, there's no restrictions. So every Asiga user, even back to our Pico systems, have access to all of the same areas that a new user today would have. So we don't restrict or limit access to software, firmware, or material profiles.